Department of Agronomy at Iowa State. And today I'll be co-chairing this session with Dr. Shuzhang Fei, who is professor in Department of Horticulture. And it's my pleasure to introduce our first speaker of this session, Dr. Erwin Goldman. Dr. Goldman is professor of horticulture at the University of Wisconsin-Madison. The title of his today's talk is Not Your Grandmother's Beet, Breeding Biennial Vegetables for Specialty Market Classes. So please join me in welcoming Dr. Goldman. Thank you.
Thank you, Arti. So lurking somewhere in the dark corners of your childhood memories, the table beet strikes fear in the hearts of some people. It's an intensely pigmented vegetable that stains everything and tastes like dirt. And something maybe you associated it with older people or with the huddled masses of our ancestors and their ancient ways. Yet you may also remember people who loved beets and couldn't wait to eat them and can them and pickle them throughout the fall and the winter and stain everything in the kitchen when they were boiled and peeled. So I would say that the predominant theme for this vegetable is its polarizing nature. I mean, some people love it, some people love it a lot less, and I think it's an acquired taste. And certainly many kids dislike it, my own kids included, who said that eating beets was a little bit like licking a playground. And this is the joy of breeding a vegetable that brings out such strong feelings in people. In fact, this may be the only crop, the only vegetable, where there's a board game devoted to, when you win the game, you give away all of your beets. That game is called Bad Beets. So imagine that with a game like that. You know, sometimes you wonder if it makes sense to breed this. Maybe we should just let it go extinct. But it is a fantastic crop. And part of this polarizing quality revolves around the volatile organic molecule geosmin. Geosmin is the smell of soil, and it is the smell of rain, and it is found in certain foods like beet and chard and spinach and a few others. It is produced by Streptomyces bacteria in the soil. Humans are exquisitely sensitive to geosmin, and we can detect it at levels of 100 parts per trillion. So there is something about it that it connects us. But for some people, it's a repellent, and for other people, it's an attractant. And at least one fragrance company, Demeter, now makes a fragrance called petrichor, which is essentially a modified geosmin molecule. It's the smell of rain, which is sold as an attractant. It's a perfume. And so again, what some people are attracted to, other people are repelled by. We know a little bit about geosmin biosynthesis from prokaryotes. Nothing on the eukaryotic side, but in the prokaryotes we know that farnesyl pyrophosphate is converted into geosmin in a relatively simple reaction. There are a couple of enzymes that do this. But we know nothing on the eukaryotic side. And I want to get into that in just a moment. And my own association with this vegetable goes back to the older people in my family, my grandparents who came from Eastern Europe and this region around Ukraine and Russia. This vegetable was of great importance there, and it still is today, of course. Beet was a very simple, staple food. It was a peasant food in many of these regions, and it was something that sustained people, and actually, interestingly, their animals too, through the winter in the form of soup and in the form of stored roots which were boiled and roasted. And this is actually a picture of my grandmother in 1954 who would have said, if she were here today, billig wie borscht, which basically means as simple and as inexpensive as borscht. This was a staple food. Now, when I started working with beets in the early 1990s, I noticed that there was all of a sudden an interest, an uptick in interest in this crop. And this was partly inspired by influencers like Martha Stewart, who started to write about it in her magazine and talk about it on her show. She was rediscovering this old-fashioned vegetable, the flavors and the colors and the textures. Chefs started to pair beets with goat cheese and walnuts, and this became a ubiquitous salad that's found everywhere now. And the beet became a resurgent crop, both on the fresh market, in salads, you saw it in farmers markets, and people began to become very, very interested. It almost was, and it almost has been for the past 30 years, a beet renaissance. The number of farms in Wisconsin growing beets more than doubled between 2012 and 2017. We now have over 550 farms that grow beets. And Wisconsin and New York, which are the two largest beet growing states, produce a lot of this crop, way more than they did 30 years ago, with a value of $14 million. Not huge by many crop standards, but big for this particular vegetable. And so in many ways, this old-fashioned vegetable got a new life. It became of interest to people. They started using it, and they started interacting with it. Part of this was the diversification in the market. And it is fascinating to see the number of ways people began using this crop. Baby leaf salad, small beet and small chard leaves were very important in salad mix, which became important in the 1980s, 1990s, and are extremely important today. We also have a steamed peeled product that came out of the UK. This is a United States company, Love Beets, that's based in New Jersey, that makes this steamed peeled product. This can be used fresh. And this also diversified the ways people would eat this crop. People made noodles out of beets. They made dye out of beets to dye certain processed food products like chips in this picture, but also yogurt and ice cream, drink mixes and soup mixes. And within the last 10 years, the nitrates that are in beets are thought to affect nitric oxide metabolism, delivering more oxygen to cells. And this has caused endurance athletes to get very interested in using beets, beet powder, beet juice, before and during their athletic events. And this has elevated beets to kind of a superfood status. And finally, I'll say that beets are substituting for meats in many cases, and people who are interested in plant-based diets are using this, not just for beef, but for fish. In this case, the golden beet, when it's spiced properly, actually even looks like salmon, and this thing looks like sushi. So I guess we could say in the last 30 years, beets are like having a moment. You know, they're just, it's like an old vegetable that people started to get interested in again, and now it is just a very exciting, I'm just so happy to be involved with it at this time. And I'll tell you, in case you don't know this already, 2022, beetroot is the color of the year according to the KitchenAid people. Okay. Now, I want to, in part two, I want to share the process that we went through in developing what we think might be a new market class of this vegetable. And it starts, like so many things in horticulture, with culinary, with taste. We interact with these foods, and we taste them, and we like them or we don't like them. And my own kids, when they were little, they'd come to the field with us. And if we were in a carrot field, I could peel a carrot and give it to them, and that was fine. But if I gave them a chunk of a raw beet, they'd say, that tastes like dirt. And I became interested in seeing if we could use breeding to change the flavor of this crop. Also, I wanted to respond to what was absolutely overwhelmingly the most common consumer comment about beets. People would say, can't you do anything about the fact that they taste like dirt? So working with my colleague Nick Breitbach, we worked together for many years. We had the idea of selecting away from not only the earthy, intense earthy flavor, but the astringency associated with oxalic acid that gives a strange mouthfeel to the beet. And the question we were asking is, could we breed a beet that was lower in earthiness that would attract consumers who were interested in just a sweet, crunchy root vegetable? And so we began that process. We were also interested to see if we could select for alternating red and yellow pigments on the supernumerary cambia. The supernumerary cambia, these are alternating xylem and phloem layers. This makes up the table beet itself. And we wanted to see if we could replace the red and white on that heirloom Chioggia variety that we absolutely loved with red and yellow concentric circles. We were also interested to see if we could change the shape. And you'll see in there, in this slide, an heirloom cultivar called Cylindra, which has a cylindrical shape. It looks like a carrot. And both Nick and I loved the feel of the carrot-shaped beet when we were in the kitchen working with it. It's just easier shape to work with. So these were some of our objectives. And we spent 16 years working on pedigree selection and half-sib family recurrent selection on beet flavor. I could show you a lot of pictures of that, but I'm just going to show you one or two. Beet breeding, like many types of plant breeding, is a messy enterprise. You get dirty doing it. These roots live in the soil. And we spent a lot of time pulling, tasting, and selecting beets. The half-sib family recurrent selection programs that we did resulted in large family numbers that required a lot of tasting. And this work was very laborious, but also very rewarding. We would take our selected beets, vernalize them, bring them into the greenhouse where we would flower them, cross them, and make seed, all within 1 year, taking this biennial plant and making it into an annual plant for breeding. And after about 16 years, we released the first Badger series beets that look like this. They're elongated yellow beets with a red swirl on the inside, and they have very, very low levels of earthiness and low levels of oxalic acid, and so they can be eaten raw. And this is why we think this is a new market class. We got pretty close on the red and yellow concentric circles. I think this is pretty good, but we still need a little bit of work on these. And in the last 7 or so years since these have been out in the market, it's been really interesting to see how people have reacted to them and how chefs are using them, how you find them in restaurants, how consumers are using them. And we hope that they will become the gateway beet for people, that they will start to get into this vegetable with this easily accessible, sweet, crunchy thing that is not very earthy. And so as you see them in the marketplace now, it's been fascinating to talk to people about how they're using them. And you know, one of the things that this made me think of was all the things in plant breeding we do to get rid of stuff. We get rid of the seeds and the thorns in watermelon and in blackberry. Rick Watson got rid of the tearing factor in onion. He's produced a variety there. There's a breeding program to get rid of the caffeine in coffee. Michael Mazurik got rid of the capsaicin in the habanero pepper, which leaves the habanero flavors but no heat. And there's a biotech company, Pairwise, that's doing gene editing to get rid of the bitterness in mustard greens. And we could probably think of dozens more examples. The Beet project that I'm talking about here is like this. We're trying to remove something. And for all of those people who I've encountered over this 30-year process who say, hey, could you stop messing around with our food? I say the same thing to them. That's all we humans have ever done, is mess around with your food. One of the great plant breeders, Norm Simmons, said plant breeding is just the current phase of crop evolution. These crops are moving through time. We are selecting them for traits, and who knows what they're going to look like. Maybe in 100 years, the beet will grow on a vine in clusters. I don't know what it's going to look like, but this is what plant breeding does. Another thing that I think we should be very proud of as plant breeders, Peter Breding referred to it this morning as the long view. Plant breeders are the type of people who are patient enough to wait for a result that takes a long time. This is what I look like at the beginning of the process. This is what I look like in the middle, and this is my predicted phenotype. And I can't wait to see what happens, even though, you know, I'll look like that. It takes a long time to do this work, but it is so deeply satisfying to be involved with it. One of the things that's been satisfying for me about this project is, in retrospect, to learn about the biology that we changed. And part of this is because we didn't have the tools when we started. We now have headspace solid phase microextraction, SPIMI, a SPIMI method for GC mass spec, which allows us to precisely quantify the geosmin molecule. This is something that we couldn't do at the beginning of the process. And this, you can take a beet, you can tag it, you can make a slurry out of it, and you can inject it in this machine that'll trap the volatile, and we can precisely measure it. So this has let us kind of go back and look at the cycles of selection that we've done, and we've learned a lot. I'm just going to give you a few data highlights here. Amy Friday, one of our former graduate students, showed that beets and chard have characteristic geosmin signatures. That is, no matter what environment you seem to grow them in, they produce roughly the same amount of geosmin or the same ranking of geosmin. So it's quite stable across environments. Solveig Hansen, another former graduate student, did also studies that looked at G/E for this trait and found that it is surprisingly consistent. This suggests to us that environment doesn't play a huge role in geosmin, and if geosmin is due to Streptomyces bacteria in the soil, that's kind of an interesting finding. Lynn Mayer, another one of our former students who's now a carrot breeder at Bejo Seeds, did bidirectional half-sib family recurrent selection over 4 cycles and was able to increase the amount of geosmin in the high population over 90% and decrease it more than 80% in the low population. Geosmin is exquisitely sensitive to selection, and it responds really, really well. Lynn also showed that if you take beets and you grow them in sterile tissue cultures, there is no Streptomyces bacteria in there. They produce relatively high levels of geosmin. In some cases, they produce more geosmin than plants grown in either the field or the greenhouse. And this demonstrated to us that the beet is producing this compound endogenously for reasons we don't understand. It's producing earthiness, and that earthiness is very responsive to selection. Currently, Adam D'Angelo is looking at temporal patterns of accumulation of these flavor traits, and he's also looking at diurnal patterns of accumulation because we want to understand a little bit more about why the plant might be making these compounds. And finally, I'll mention that Solveig Hansen did a QTL study in which she found a major QTL for the flavor trait of geosmin on chromosome 5. And we're zeroing in on some candidate genes on chromosome 5 now that we hope will yield some interesting results. Part of this is with a GWAS. This is taking place in 2022 and 23, and this is an aerial view of one of our GWAS locations growing a very large diversity panel that includes not only table beet and chard, but also sugar beet, fodder beet, and some wild material. None of the work that we did would have been possible without strong collaborations, and if every single presentation that I've listened to at this conference, the collaborators, you can tell the importance of that role of the collaborators, and the same is true for us. This is Kevin Dorn on the left from USDA Colorado State University, and Mitch McGrath on the right, also USDA Michigan State University. These two took one of our inbred lines and made the first table beet reference genome, and are providing tools for us that will allow us to do some of this work that we need to do for the coming years, and I'm incredibly grateful to both of them. Well, I'm going to conclude my presentation with this 4th section to talk about the releases and sort of what this might mean for the new market class. We've created these beets. They look like this. They're pretty. To me, I like the way they look. They're very accessible. If you sliced it open right from the field and you just chomped on it like you were eating a carrot, it would be a pleasant taste, and you would just barely taste any earthiness at all. It would be mostly sweet and crunch. And it is it's nice to see it out in the market, but some people don't recognize this thing as a beet. It looks a little bit unusual. It looks more like a banana, I suppose. And so we have now released a round version that has many of the same, probably exactly the same culinary qualities and visual, but it is more recognizable. And so we hope this one will also be of use in the market. Solveig Hansen, through a participatory breeding program with chefs and farmers, released 4 cultivars, 2 of which are low in earthiness and 2 of which are high in earthiness. The 2 low earthiness cultivars are Snow Globe, which has white flesh, and Evansville Ember, which has red flesh. The high geosmin cultivars are Moving Target, which does look a little bit like that Chioggia beet that I showed you, and Blushing Not Bashful, which has a pink blush on the exterior and it has yellow flesh. The high geosmin have a unique earthy flavor, and some people, maybe even some of you out there, like the earthiness in your food, and some people really want to stay away from it. And so we hope we've made these flavor-defined cultivars for those groups of people. And as I said earlier, it's interesting to see this new market class in the retail space, both in the grocery store and in restaurants. The middle panel is a picture from the Sweet Green restaurant, which is a restaurant chain across the United States that serves salads, and they're using this fresh in their salads. And it's interesting to hear consumer comments, and it's something that we can respond to as breeders. This is a painting done by a pretty famous American painter in the early 1800s, not that long after our country was founded, and you see the beet there. And this is what beets looked like at the time, and we still have beets that look like this, and they taste very, very earthy. And I'm really glad we do, because I think this is the sort of foundation, and this is the crop that people have been using for many, many centuries. But it's also been rewarding to be part of modifying modifying the taste profile into a different market class that hopefully can mean more people enjoy this vegetable. So many students participated in this work over the years. I've just listed some of our graduate students from the last 5 years on the left side of this panel and some of our current grad students and postdocs on the right side of this panel. All of them have had hands in these projects, and the work, as you know, in plant breeding could not be accomplished without all of their help. I'd like to say a special thanks to Warren Buck Gobelman, who started our lab, our table beet breeding lab, in 1949 after he came out of World War II, and he passed away in June this year at the age of 101. None of our work would have been possible without Buck. And I'd also like to say a special recognition to our spiritual home, the Carrot and Beet Lab on Willow Creek on the Madison campus, where hopefully we have some of our good ideas. Thank you all for your attention.
We have time for one question. No? A quick question if you have, otherwise we can move on to next speaker. Yeah.
Hi, how do the low geosmin beets taste pickled?
They actually are pretty good pickled, but I think they don't have the same kick as the original beets. So I think they're really made to be a fresh product. Thank you for the good question.
Thank you so much, Dr. Goldman. Please join me in thanking Dr. Goldman for an excellent talk.